All right, so let's find some equations of lines. Go the other way in where we have some information and go to the equation of the line. For example, number 1. Find the equation of the line with slope 2/3 that goes through 4/7. Okay. So essentially we've got, we could graph this just from that information, but we want to find the equation that goes with that. Okay. All right. So yeah, this is what I do. What I like to think, if it says find the equation of a line, and it's not a vertical line, because a vertical line is x equals a number, but any other type of line besides a vertical line, you can always say, I'm going to find y equals mx plus b, or that's usually what you're trying to find. And so this is the way I go about it. Now, if you would like to use the point slope form, fine, but they're going to want the answer in slope intercept form. So find the equation of the line, that's the form we want, and so that's where I start even with it. All right, well, to finish off this equation, I need to know two things. I need to know the m and the b. And fortunately, I have one of those provided, the other one not so much, right? Which one of those do I have provided?
Yeah.
Yeah, so I got the m. The m is the slope, so I can plug that in right up front. Now it's just a matter, right, of finding the b. Well, good news about finding b here is I just so happen to have an x comma a y, don't I? Mm-hmm. And so to find the b, I can just plug in that x and y respectively. That'll find my b. Y is 7 and x is 4. Yeah, so that allows me to find my value for b. 4 over 1, so that's 8/3, multiply across. So all I'd have to do is subtract 8/3 from both sides, and that's my b. And, that one's not a nice terminating decimal or anything, but it's not too hard. 7 is 21 over 3, minus 8 over 3, so what's b? 13 over 3. Various ways to get that, but yeah, the b is going to be 13/3 or some equivalent to that. So it's y equals, so the equation, that's not the answer. What's the answer? It's y equals mx plus b. Y equals 2/3 x plus the b, so plus 13. Okay? Yes? All right? All right, well, of course, what they won't always provide us exactly that information. So here, what about this? Let's find the equation of the line that goes through 2 points, 2, 9, and 4, 3. Find the equation of the line that goes through 2, 9, and 4, 3. All right. Still trying to find the equation of the line, so we're looking for, and probably it would state the equation of the line in slope-intercept form, and so that's what let's just start there. Y equals mx plus b. That's what I'm trying to find. Now, is m or b given here? No. However, 2 points are given, so what can I find?
Slope.
I can't find the slope using our slope formula y2 minus y1 over x2 minus x1, right? See what that gets us. 3 minus 9 over 4 minus 2. Negative 6 over 2, so I got a negative 3 is my m. Is that right? Do that one right? Okay. So I got y equals negative 3x plus b. Now I just need to find out what the b is, and now, which one do I use? I've got an option here. Either one works. Maybe one is easier than the other. Plug in this for x and y, or plug in that for x and y. Either one, if we do it this way, either one's okay. Let's just go with the first one. This is x, this is y. 2 for x, 9 for y. So that makes 9 equals negative 6 plus b. So my b is 15. Believe that? Yes. So that's y equals, the answer is y equals negative 3x plus the 15. Okay? All right. Yeah, the trickiest maybe to get on that, I guess they could throw in a vertical line or something like that. I don't think so, but third one, find the equation of the line through 4.2, negative 3.5, and 5.0, negative 6.4. Yeah, that's not that bad, but let's talk about it. So again, we got 2 points. So start with your slope formula. What do we got? Negative 6.4 minus a negative 3.5 divided by 5.0 minus 4.2. Does that sound right? Bottom 0.8, what's the top?
0.8, or the bottom. Sorry.
The bottom's 0.8, the top is negative 6.4 plus 3.5, what's negative 2.9? Yeah, and I guess that's kind of the reason I'm... All right, so that's not going to be a nice decimal. If we go to decimal, the other option here is use a fraction, and that's, if you want to use a fraction, that's would be 29 over 8, negative 29 over 8. But if I go to the decimal, it's negative 3.625. Okay, so that terminates pretty nicely. We may just want to keep it negative 3.625. Could round it, negative 3.6, based on accuracy here. We'll just, because it's a nice enough one. So it's y equals negative 3.625 x plus b, and then just plug in our x and our y, and go from there. All right. 15.25. So add the 15.225.
$11.725.
Thank you. All right. So like I said, it's not that terribly difficult. Any question or concern about those? We're good? All right. Well, the last thing that I wanted to talk about is come off of this handout here. Got another set of data here. This is enrollments at Lincoln University. And this one, 0 to 9. gets one. We going? All right. Yeah, so we've got this table here. We've got year and enrollment numbers for Lincoln University, 2010 to 2016. 2010, we got 1475. 2011, 1500. 2012, 1510. 2013, 1560. 14, 1640. 1690, 2015, 2016, 1720. Get those up there right? I believe so. Okay, so number one, yeah, we talked about scatter plot, so let's just put a scatter plot in for this one. All right, so yeah, our data is upper right quadrant. We'll let the X here represent the year on the X-axis, and then the enrollment on the Y-axis. And let's just cut it down to 10 here. 10, 11, 12, and we'll just start 10 here, 11, 12, our year. Just label it to make sure. So that's the year, 10 is 2010. Okay? And then our enrollment will go on this side. Yeah, we got basically 1400s to 1700s, so probably should mark that off 50s, something like that. So we'll start here at 14, well, let's just start at 1450. And then 1500, 1550, 1650, 1700, and 1750. I did that right. No, I didn't do that right. One more. All right, 14, 15, 1550, 16. All right. Yours could look somewhat different, but scale it off where you put those numbers on there nicely. All right, so that's enrollment numbers, number of students. Lincoln University. So that's our scatter plot. Oh, didn't put in the numbers here. 2010, we got 1475, so that's kind of the middle there. 2011, oh, right at 1500, so that'd be here. 2012, we got 1510, it's right above. 2013, we got 1560, so 15 and then 10. Go right there. 2014 is 1640. Not quite 1650. 2015, we got 1690. Not quite to 1700 right there. And then 2016, we got 1,720, kind of in the middle here. All right. Scatter plot. So that's what we did in the previous section there. Well, number two, we're going to take it another step here. We're going to draw, let's call it a line of best fit. Draw a line of best fit. Here's what I mean by that. Yeah, these do seem to be progressing rather nicely in more or less a line sort of way, right? I mean, it doesn't go in a straight line, but that's what number two is about here. I want a line that I would say is a pretty good fit for that. Now what do I mean, or what am I looking for here? Well, I wouldn't want to draw a line like, well, mine anyway. If I drew these two, that would not fit it. If I went through these 2 points right here, that would not fit that model, this data very well, would it? Because it veers off, it doesn't kind of hit those. So what I'm looking for is just kind of a line that goes through the middle. And I would use 2 of the points because we're going to find the equation of that line. That would be our next thing. So looking here for a line that goes through the middle, and whatever points, I mean, you may pick 2 different points, but it looks like if I went through these 2, with how I've drawn it anyway, that does a pretty good job because I've got some above, some below. So that's what we're looking for. Just something that goes kind of down the middle of the data. Sticks to most of the data pretty well. Okay? With me there? Questions or concern about that? All right. So number 3, using t equals 10 for the year 2010. So I'm going to call the x-axis the t-axis, t for year, that time. That's a lot of times what you'll see. So these are going to be t values here, as opposed to x values. Find a linear model for the data based on the line of best fit you drew in number 2. Okay, so here's what I did, right? I used 11 and 14's points for the year 11 and year 14. Well, 11 was 1,500, and then 14 was 1,640. If you pick 2 different points, you're going to get a slightly different answer than these, and that's okay on these because it's very subjective on which 2 you pick. So based on the 2 I picked, though, here's what the line of best fit would be. Well, it's the equation between 2 points, right? What we were just talking about. I would take, I want to find the line of best fit, so in this case, I guess I'm going to call it, let's just call it E equals MT plus B, and we can, that's what I'm looking for. E for enrollment, just to make it kind of descriptive, the letter. I mean, we could use Y equals MT plus B, that'd be fine, but E for enrollment, that's going to be my model. I need to know the M, I need to know the B. Well, neither one of them are specifically given, but again, like I said, I went through those 2 points so I can find the M, right? M is just going to be the difference of the Y's over difference of the X's. In this case, difference of the E's over difference of the T's, I guess. But same drill. I'll do these 2, subtract the top, the Y's, and then subtract the X's. The way we phrased it, but with me there? That'll give me my slope. Same thing. 140 over 3. And I mean, you can use the decimal if you like. I'm going to round it off. Let's round it off to 1 decimal place. 46 point, let's call it 46.7 on mine. Except if you did 2 other points, you may get a slightly different answer, but it should be a positive number, and pretty large positive number. Is that okay? All right, so now I've got E equals M, 46.7 T plus B. Find the B, just plug in an E and a T, right? So I've got an E. I want to use one of the ETs from these 2, not some other 2 points. So let's just go with this one. 1,500 for E, 11 for T. So 1,500 equals 46.7 times 11. 513.7. So subtract that, and we got our E.
986.3.
Thank you. 986.3 is my V. So just plug that in, and there's my model. That's number 3. All right, then of course, we can do whatever we want to with that, find some different things based on that model, but the one I'm asking about on number 4 there, using the model predict the enrollment for 2020. The enrollment for 2020. So based on mine, what would we do there? 20 is plug in for T. Yeah, that gives me the year, that gives me the time, the T value. 10 was 2010, so 2020, that means T equals 20. Yeah, I plug that in. That'll give me a prediction for that enrollment. All right. 6.7 times 20 plus 986.3. I get 1920.3, and of course, we're talking about students here, so we'll just call it 1920. 1,920 students is what this model would predict. Okay?